So today I'd like to talk about stoichiometry map, and let's say we have a chemical reaction A plus B producing C plus D. Okay, using the stoichiometry map or stoichiometric concept, we can always identify the amount of the C from the from B, or amount of the product D from the reactant A, or reactant B to C, or reactant B to D. Okay, we can always find the different amounts, right? So let's say we have 2.0 mole of the compound B. Okay, to find the like molecular amount of the moleculars or atoms of this compound B, we can always use the Avogadro's number to convert it, right? Same thing, if we want to convert this amount of mole to gram, okay, which means mass, to convert this, we can always use the relative molecular mass to convert it, right? And if we want to convert the compound B to compound C, okay, so let's say we have unknown amount of the compound C. Okay, so to find the unknown amount of compound C from the known amount of the compound B, what we need to do is we need to use the mole ratio to convert it. Okay, so means like in this case we have a like, let's say we have 1 to 1, so 1B goes to 1C. Okay, then in this case it's going to be 1 to 1 ratio. Okay, same thing, if we want to convert the unknown amount of C in mole, okay, to moleculars or atoms, we have to use the Avogadro's number. Okay, and if we want to convert this mole to mass, which is in gram, we have to use the relative molecular mass. Just remember this, whenever you want to convert from one compound to another compound, you always need to use mole ratio. Okay, and their unit, the known amount unit, needs to be in the mole. And if you want to convert from any number, okay, so it means if you want to convert from mass to like molecular, you always have to go to the mole and convert to the moleculars. Okay, so I want to talk about the like relating the mass and with the molar mass. Okay, so first example, how many moles of the water are present in 27.03 gram, right? So water is H2O. Okay, so to convert the gram, which is the mass, okay, mass, the unit is gram, right, to mole, we have to use the molar mass, which is the MR. Okay, so the first step will be calculating the MR of the H2O. So we have 2 hydrogens here and 1 oxygen. So we have 2 times 1.01 plus 16, which is equal to 18.02 gram per mole. Okay, so using this number, we're going to calculate the mole of the water. Okay, so we have a 27.03 gram of the water, right? And we want to convert this to mole, so we're going to keep the mole as the numerator, and we're going to keep the number, the mass, as the denominator. Then we can cancel up the unit gram, and the final answer is 1.5 mole of H2O. And we have 4 suffix here, so the answer will be 1.500 mole of H2O. Example number 2. We have to convert the mole, okay, to mass, right? So this time we are converting the mole of iron 3 oxide to the mass of iron 3 oxide. Okay, so we're going to same thing, we're going to use the molar mass, right? So first find the molar mass of the iron 3 oxide. So it's going to be 2 times Fe plus 3 times oxygen. So it's going to be 2 times 55.85 plus 3 times 16. So the answer is for this part is 159.70 gram per mole. Okay, so using this number, we are going to calculate the mass of the iron 3 oxide. So let's start with the mole of it. So it's 4.40 mole of the Fe2O3, right? And we are converting this to mass. So we keep the number 159.70 gram as the numerator, and we're going to keep the mole as the denominator. Okay. Then we can cancel off this unit, and our final answer is 702.68 gram of Fe2O3, and our Cefic from the question is 3. So our final answer should have the answer 703 gram. So 703 gram Fe2O3. That's the final answer. Example number 3. So we have 1.30 moles of the unknown compound that has the mass of the 20.9 gram, right? And it's asking for the molar mass. We know that the molar mass has unit gram per mole. Okay? And we have unknown compound that has the mass 20.9 gram and has the mole 1.30 mole. Okay, so to find the molar mass of this unknown compound, we just do 20.9 gram divided by 1.30 mole. Okay, then we get the final answer, 16.1 gram per mole, and the Cefic is 3. So we keep it as a 3 Cefic.